or you are interested in. And success is in quotes because we associate good things with success, but here it's just one of two possible outcomes from a trial, and it could be positive or negative. That's not the issue. It could be a good thing or bad thing. That's not the question. It's just you got outcome one or not. Okay? Number of successes you are interested in. Okay. So let me just expand. Go back to these examples here. So you flip a coin 7 times. Every time you flip a coin, the probability of getting heads is 0.5. And I might ask, what is the probability the coin lands heads four times? Okay? So you flip a coin 7 times. The coin could land heads 3 times. It could land heads 4 times. It could land heads 6 times. It could land heads all 7 times, okay? But what I'm asking is if I flip the coin 7 times, what's the probability that the coin land heads 4 times? So to answer this, what is my n? 7. What is p? 0.5. And x? X is 4. Okay? N, p, and x. Let's look at this next problem. We play a game of chance 4 times. Every time you play the probability of winning is 0.3. What is the probability I win 1 time? 1 time. This is different from at least once. Okay, this is the probability of winning 1 and only 1 time. Okay?
You're talking about what's the probability of winning 1 out of 1 times?
1 out of the 4 times.
Oh,
okay? What is the probability I win exactly 1 time out of 4 games? Okay? Does that question make sense? I'm playing it 4 times. I want to know what's the probability I'm going to win exactly 1 time out of the 4 games. Okay. So what is my n? N is 4. What is p? 0.3. And what is x? X is 1. Okay. So to answer this, we go to our binomial probabilities table. Okay. And you'll notice on the very left, so when you read the problem, you figure out n, p, and x, but when you look it up in the table, you look up in the order n, x, and then p. Okay? So on the very left, you find your n. So we're going to do the first one first, okay? So n, you go to where it says 7. Okay, you have n, x, and then you have p. Okay? So you find n is 7, and then starting at 7, you have x, 0, 1, 2, 3, 4, 5, 6, 7. Okay? So you go to n is 7, then you go to x is 4. This is the row that you are now in. Okay, everybody see that? N is 7, x is 4. Okay, now we're going to find the column that corresponds to p equal to 0.5. So you look at the top, and you go to p is 0.5, and what do we see there? 0.273. Okay? N is 7, and then starting there, you go 0, 1, 2, 3, 4. You go to that row 4, and you go to the column 0.5. I think, and you get 0.273. Do you see that? Okay. And so the answer here, if I flip a coin 7 times, and every time I flip the coin, the probability of getting heads is 0.5. What's the probability the coin lands heads 4 times? The answer 0.273. I play a game of chance 4 times. Every time you play the game, the probability of winning is 0.3. What is the probability I win exactly 1 time out of 4 games? So I'm going to go to n is 4, x is 1, column 0.3. And what is the answer I get? 0.412. That's not too bad, right? Okay, so let me just do one problem. I'm going to write it up on the board. Actually, I'm going to write 2 problems up on the board, just to illustrate that the hardest part is knowing when is it a binomial problem versus when is it not. Okay, I'm going to put 2 questions up on the board that you will be able to answer both of them. One of them is binomial, and the other one is not. Okay. Play a game of chance 3 times. Each time you play, probability of winning is 0.7. What is the probability you win or you lose? Well, both of them could be binomial actually, but whatever. You play a game of chance 3 times. Each time you play, so the first one says you play a game of chance 3 times. Each time you play, the probability of winning is 0.7. What is the probability you lose at least once? The next one says you play a game of chance 3 times. Each time you play, the probability of winning is 0.7. What is the probability you win 2 times or 3 times? How are we doing this? Yay, NP and X, okay. Alright, so what about this one? You play a game of chance 3 times. Left up. There's a chance. Each time you play, the probability of winning is 0.7. What's the probability you lose at least once? Does that sound familiar? Okay.
0.3?
Huh?
0.3?
Alright, so this one is a little different, right? Remember from our quiz, we're looking for the probability of losing at least once. That would be 1 minus the probability of winning all 3. Okay, so this one's going to be 1 minus the probability of winning all 3. Okay, and so there's a couple ways we could do this. We could do 0.7 raised to the 3. Because that's the probability of winning all 3, right? 1 minus 0.7 raised to the 3. Is that okay? And we would get that. Probability of winning 3 out of 3 is actually also a binomial problem. What would I have to look up for this one? N is 3, P is 0.7, and X is 3. Winning all 3 out of 3 is 3, okay? And so if you look up if you did the math for 0.7 raised to the 3, you get 0.343. Okay, so you have 1 minus 0.343. Okay, if you look up NPX 3.73, you would also get 0.343. All right, and so both of these can be answered with 1 minus 0.343, which gives us 0.657. You guys write that down. Over here, let's try this one. What, was this problem okay? Okay. You play a game of chance 3 times. Each time you play, the probability of winning is 0.7. What's the probability of winning 2 times or 3 times? So here we have NPX, but we have 2 x's. Okay? N is 3, P is 0.7, and x is 2 or 3. So I look up NPX for x equal to 2, and the probability is 3, 2.7, I get 0.441. And then for x equal to 3, the probability is 0.343. Okay. So the probability of winning 2 or 3 times, what would I do? I would add those 2 together. So the probability of 2 or 3 wins would be 0.441 plus 0.343, and I get 0.784. And there is our answer. We have a question.
So the n for the x equals 3 is the same as the first one?
Yes. Yeah, the n and the p are the same for both of these because we're repeating the same trial 3 times every time we play. Probability is 0.7. And it's just the x's that are different. Okay, that's it. Thanks for enduring the evening. We'll see you guys next week. Good luck as these guys study.
Good question.